For topic 3, we're going to actually do division of whole numbers. So we're going to look at this idea of long division, okay? And I've told you this before in different videos. Sometimes when I write out the steps don't totally make sense until you see it applied to a problem. So just bear with me while I go through these steps. And then when we start looking at actual examples, pay close attention to how those steps really apply to the individual problems, okay? So the first thing we want to do as far as steps for dividing whole numbers, we want to set up the problem, and I've written it up over here. We want to use this setup. So I showed you this in a previous video for this worksheet. We want to do the long division setup where you put the dividend inside the division bracket, or I used to call it the house when I was younger, and then you put the divisor on the outside. That is the long division setup, okay? Next, we determine how many times the divisor can fit into the dividend. Once you figure that out, you multiply the divisor by whatever quotient you found from the previous step, and then you subtract that from the dividend and find the remainder. The issue is sometimes we can't do this all at once. We have to do this piece by piece, step by step. So instead of saying, hey, the dividend is divisible by the divisor this many times, we may not be able to see that. So we'll say, okay, how many times will the divisor go into the first digit of the dividend? Or how many times will the divisor go into the first two digits of the dividend? And then we subtract, we find a remainder, and then you drop down the next digit in the dividend and you repeat the process. So that's kind of how we do this piece by piece. Again, it may not completely make sense now, but pay close attention to how these steps apply to the actual problems in just a moment. Okay. So again, we may have to repeat this process. So steps 2, 3, and 4, we may have to repeat those multiple times as we go through these problems. Okay. Another thing I want to point out is there is a way to use a multiplication table backwards to help out. So I'll try to show you how a multiplication table can be of use to you if you're not really good with your multiplication tables yet, okay? Now, the multiplication table that I have is a 30 by 30, so if your divisor is more than 30, this table won't really work, okay? Now, for example 4, it says find each quotient, include remainders when applicable. So we're going to start going through these steps now, okay? So part A, we have 4,908 divided by 6. So I'm going to start with the long division setup. So 4,908 divided by 6. Okay. Now, right off the bat, I can't tell you how many times 6 goes into 4,908. If we could do that in our head, we wouldn't need to do this idea of long division. We would just say what the answer is. But long division allows us to do this piece by piece. So since I personally don't know how many times 6 goes into 4,908, I want to see if I can do this piece by piece. So what I would do is say, will 6 go into the first digit? Well, the first digit of the dividend is 4. 6 won't go into 4. So I want to look at the first two digits of the dividend. Okay, the first two digits of the dividend are 4 and 9, so 49. I can ask myself, how many times does 6 go into 49? Well, I happen to know that 6 will go into 49 8 whole times because 6 times 8 is 48. So I would say 8, and then 8 times 6, I want to multiply these. 8 times 6 is 48, and I want to subtract that. So I look at 49 minus 48, that's just 1, so that's my remainder, but I want to bring down the next digit in line. So I'm going to bring down the next digit, which is a 0, and then I'm going to repeat this process. So it's kind of like a lather, rinse, repeat situation. Now we ask ourselves, how many times will 6 go into 10? Well, 6 will go into 10 one whole time. So I put a 1 up here for the quotient, and then I say 1 times 6 is 6, and then I subtract that. Well, 10 minus 6 is 4. I bring another digit down. So I bring down an 8, and then I repeat the whole process. Once you bring something down, you have to try the division. You have to do a whole cycle. So if you bring something down, you have to put something in the quotient, multiply, subtract, and keep that process going. So we brought down an 8. That means we have to go ahead and divide one more time. 6 will go into 48 8 times. 8 times 6 is 48. I subtract. I get a 0 remainder. Once you get a 0 remainder and there's nothing left to bring down, you know you're done. So we would say up here that the quotient is 818. So I would say 4,908 can be broken down into 6 equal size groups. The groups are of size 818. So 4,908 divided by 6 is 818. Okay. Now we can check this with multiplication. You don't always have to check. Just know that you can. So I would take 818, my quotient, I would multiply it by my divisor, which was 6. Well, 6 times 8 is 48, so I keep an 8. I carry a 4. 6 times 1 is 6, plus 4 is 10, so I keep a 0. I carry a 1. And then 6 times 8 is 48, plus the 1 I carried is 49. Since that's the last multiplication, I write out the full 49. So 4,908. Everything really does check out here. Okay. Now, when it comes to the multiplication table, I want to show you kind of quickly how I could use the multiplication table. So in that very first step, we had to see how many times 6 would go into 49. Let's say you couldn't see that. You're not really up to date on your multiplication tables. You're like, I don't know. So you can go to a multiplication table. So remember 6 and 49. All right, so here's a classic multiplication table. Let me see. Can I make it any bigger? Okay, so there we have it. It's a little bit bigger. So what you want to do is you want to go down the row until you get to your divisor. So our divisor is 6, okay? And then I want to go over the row. So in the row of 6, I want to go over until I get as close to 49 as I can without going over. So I would go over. So we're 6, 12, 18, 24, 30, 36, 42, 48. After 48, I get to 54. 54 is too big. So we want to look at the 48 here, and we need to make note of which column we're in. We're in the 8th column. So that tells me 6 goes into 49 8 times. Can't go in 9 times, that would be too big. If I go only 7 times, my remainder's too big. So you got to find that sweet spot, that spot that's just right. So kind of think Goldilocks and the Three Bears. We can't use 42, we can't use 54, they're too big and too small. 48 is just right. It's as close to 49 as we can get without going over. So then you ask yourself, what column am I in? I'm in the 8th column. That tells me 6 goes into 49 8 times with a little left over. Okay, so you can use your multiplication table backwards if it's helpful. Okay, so let's go back to the worksheet. There we go. All right, so for part B, we have 45,905 divided by 9. So we're going to set up for long division first. Okay, I could not begin to tell you how many times 9 will go into 45,905. Have no clue, okay? But we can go piece by piece, okay? So I know 9 won't go into 4. 4 is too small. So I'm going to look at the first 2 digits of my dividend. So I'm going to look at 45. 9 will go into 45. So 45, that would be 9 times 5. So 9 will go into 45 5 whole times. 5 times 9 is 45, so I subtract. I get a 0 remainder, but I'm not done. I need to make sure all of the digits have come down. So the next digit in line is a 9. Well, 9 will go into 9. It goes in 1 time. So 1 times 9 is 9. I subtract. I get a 0. And be really careful here. I drop a number down. As soon as you drop a number down, you have to put something in the quotient. So if you drop a digit down, you have to do a full cycle of multiplication. So how many times will 9 go into 0? It will go into 0 0 times. You have to put the 0 up there. So then 0 times 9 is 0. We subtract, and we get 0. We drop down the next digit, which is, whoops, that should be a 5. Make sure you put a 5 there. And then we drop something down, so we have to put something up at the top in the quotient. So 9 goes into 5 0 times. 0 times 9 is 0. So I've got a 5 left over. I've dropped down all of my digits. I didn't get a 0 remainder, but I do have a remainder that's less than the divisor. So as long as this remainder is less than your divisor and you've dropped everything down from the dividend, you're done. Okay, so remember the way we can check this. We think right now our answer is 5,100 with a remainder of 5. The way we can check this is you multiply your quotient by your divisor and then add the remainder. So let's do that. We want to take our divisor, which is 9, multiply it by our quotient, which is 5,100. So let's see, 9 times 0 is 0. 9 times 0 again is 0. 9 times 1 is 9. 9 times 5 is 45. And then we need to add our remainder. So we want to add 5 to this. Well, 0 plus 5 is 5. There's nothing to add to the 0, the 9, the 5, or the 4. And there you have it. We do get 45,905. So we can say with a fair level of confidence that the quotient here is 5,100 with a remainder of 5. That means 9 will go into 45,905 times, or 9 will go into 45,905, 5,100 times, but then you're going to have this little leftover group of odds and ends of 5 that just won't make a full group. Okay, so we do have a remainder here. Let's look at part C. So the difference with part C and D is the divisor is a 2-digit number. And this does complicate things. It's a little bit harder to do the division and multiplication with the 2-digit numbers, but we have a multiplication table. Remember, we can use that multiplication table to help out. You can also use this idea of estimation. Sometimes you can kind of estimate and figure out what you're going to need to write in your quotient. So let's go ahead and set this up for long division. We have 6,580. We want to divide by 13. I want to see how many times 13 will go into 6580, but it's going to be too hard to do in my head, so we're going to do this piece by piece. So I know 13 won't go into 6, but 13 will go into 65. So let's go over to the multiplication table. So remember 13 and 65. So if you know what these are, you don't have to use the multiplication table, but I want to make sure you know how to use the multiplication table if you need it. So let's erase some of this mess that we have here from the previous example. Okay, so we had 65. We want to divide it by 13, so we want to go down to the 13. Well, hang tight. There we go. We want to go down to the 13th row. We want to go over until we get as close to 65 as possible without going over. So we've got 13, 26, 39, 52, 65. So that tells me 13 goes into 65 exactly 5 times because we're in that 5th column. Okay. So that's how you can use your multiplication table if you need. You certainly don't have to, but you're welcome to if you need to. So we would say 13 into 65 is 5. 5 times 13 is exactly 65. So we subtract, we get 0. We drop down the next digit in line, which is an 8. And remember, once you drop something down, you have to do a full cycle of multiplication. So you have to put something in the quotient. So 13 goes into 8 0 times. 0 times 13 is 0. So I subtract and I get an 8. And then I drop down the next digit in line, which is a 0. So now we want to do 80 divided by 13. So we can go back to our multiplication table. We're still in that 13th row. That's not going to change. But now we want to see how close we can get to 80 without going over. So we've got 13, 26, 39, 52, 65, 78. That's pretty close to 80. If we go one further, we're at 91. That's too big. So 65 is too small. 91 is too big. 78 is just right. And we're in the 6th column. Okay. So let's go back to the worksheet. So we know 13 will go into 80 6 times. 6 times 13, remember, was 78. Okay. It'll be a little bit easier when you have your multiplication table sitting right in front of you than for me to flip back and forth. But 6 times 13 is 78. We subtract, we get a 2. Well, 2 is less than 13, so I can't keep dividing. There's nothing left to drop down, so that tells me I do have a remainder. So we would say that the result here is 506 with a remainder of 2. So 13 will go into 6,580, 506 full times, and then there's going to be this little group of 2 left over. Okay. One more. 8,825 divided by 11. Well, 11 won't go into 8, but it will go into 88. So 11 into 88 goes 8 times. 8 times 11 is 88. I subtract, I get 0. I drop something down, which is a 2. Now, once you drop something down, remember, you have to do a full cycle, so you have to put something in the quotient. And it just so happens 11 won't go into 2. It goes in 0 times. So 0 times 11 is 0. I subtract, I get a 2. I drop down the next digit in line, which is a 5. Well, 2 will go into 25 twice. 2 times 11 is 22 with 3 left over. So we would say here the quotient is 802 with a remainder of 3. And just to remind you how to check yourself, so to check, we want to take 802 times 11 and add 3, and that needs to equal the 8,825 that we started with. So 802 times 11, well, I get 1 times 2 is 2, 1 times 0 is 0, 1 times 8 is 8. Now remember, we're really multiplying by 10 in this next row, so we have to put our 0 placeholder, then we can just multiply by that 1 in the 10. So 1 times 2 is 2, 1 times 0 is 0, 1 times 8 is 8. We add our partial products, so 2 plus 0 is 2, 0 plus 2 is 2, 8 plus 0 is 8. There's nothing to add to that first 8, so we just bring it down. And then don't forget, you have to add your remainder. So we want to add our remainder, which gives us 8,825. So everything really does check out here, okay? So make sure you understand the steps for long division. If necessary, make sure you understand how to use a multiplication table backwards. Remember, there's a time and a place where calculators are absolutely acceptable, okay? But there is a situation where we need to know that you understand the basics, okay? So there will be a time in class where we have some kind of assessment where you have to do addition, subtraction, multiplication, and now division without a calculator. Nothing crazy, really basic, okay? So make sure you understand the steps and then understand when it's appropriate to use a calculator. So whether an assessment is calculator or no calculator, you'll always have your multiplication table. So if you're struggling with your multiplication tables and memorizing those, make sure you understand how to use the multiplication table for multiplication and for division.